How does an AI really understand what you're saying? I mean, really get it. It's one of the biggest puzzles in technology. Today, we're going to dive into a pretty groundbreaking approach called MultiNet, a system designed to teach machines the actual meaning behind our words. I mean, think about it. When you ask your phone for directions or tell your smart speaker to play a song, it feels like it gets you, right? But how does a machine go from just processing sounds to actually grasping your intent? It's so much more than just recognizing words. It's about understanding a whole world of context.
So before we can even get to the solution, we have to really understand the problem. And for AI, the biggest problem has pretty much always been that beautiful, messy, complicated thing we all use every single day: language.
And this, right here, is the heart of the challenge. It's a field called semantics. See, a computer can hear the word bank, but it just sees data. It has no idea if you're talking about a place to get cash or the side of a river. For an AI to be genuinely helpful, it has to learn to tell the difference. That context, well, it's everything.
To crack this problem, researchers knew they needed a totally new approach. They had to find a way to map not just the words themselves, but the meanings behind them. And that's where MultiNet comes into the picture, a new model designed specifically to teach machines how to interpret our world. So what in the world is MultiNet? Well, at its core, it's a system for building this huge, interconnected mind map for an AI. But here's the cool part. Instead of just linking words, it links the concepts behind the words. It connects king to things like royalty and power, and rain to water and weather, building this incredibly rich web of understanding.
Now, what really made MultiNet so powerful was its design. This wasn't just some loose collection of ideas. No, it was a formal language built from the ground up for machines. This meant it could systematically classify meaning and automatically process that crazy complex web of relationships in our language, a task that had completely stumped earlier, more rigid systems.
And to really get why this was such a huge deal, you gotta look at what it replaced. You see, AI's first attempts at understanding language were based on something much more rigid.
The old way was something called classical logic. The best way to think of it is like a brick wall. It's strong, it's orderly, but it is totally inflexible. It's all built on these strict black and white rules. MultiNet, on the other hand, was way more like a spider's web, flexible, interconnected, and able to capture all the subtle nuances of language. It could actually handle the shades of gray that make our communications so rich.
Okay, so it's flexible, we get that. But how does it actually think? Let's take a look under the hood at the engine inside MultiNet that lets it make these logical deductions. The secret sauce here is something called inferential power, which is just a fancy way of saying the ability to draw new conclusions from old information. It uses a kind of rulebook called operational semantics. Think of it like a detective's guide. When you get this clue plus that piece of evidence, you can conclude this new fact. It's a system built for reasoning in context.
So here's how that reasoning process actually plays out. Let's say you ask a question, like, is Socrates mortal? The system immediately dives into its knowledge base, its mind map. It finds the rule or the axiom that says all men are mortal, and it also finds the fact that Socrates is a man. From just those two pieces, it infers a brand new conclusion: Socrates is mortal, and boom, it gives you the answer. It's like a logical chain reaction.
Now, this was a really powerful idea, but did it ever actually leave the research lab? I mean, the real test of any technology is seeing if it can be applied in the real world. And oh boy, did it ever. MultiNet's impact was widespread. It was the engine behind those early natural language interfaces, the ones that let you talk to software in plain English instead of having to write code. It was used to build advanced tools for linguists, and it even powered systems that could find an image based on a description, like find pictures of big red cars. It really became a foundational tool for a whole new generation of AI. And this quote, right here, sums it up perfectly. MultiNet became a common formalism platform. To put that simply, it was a reliable, solid foundation that other developers could build on top of. It wasn't just a single application. It was a toolkit that enabled countless others.
You know, all of this leads to a much bigger question. Systems like MultiNet create these incredibly detailed maps of language. But think about this. Is having a perfect map of a city the same as actually walking its streets, smelling the food, and hearing the sounds? As we build these ever more sophisticated models of language, the line starts to get really blurry. Are we creating true understanding or just the ultimate imitation? It's definitely something to chew on.